Hello class, this is Mr. Duncan. I decided that we needed a little more instruction, and to that end, I'm going to attempt to film me going through the notes. Hopefully my phone stays steady, and this shouldn't take very long because I'm not going to pause to ask questions. Instead, I'm going to move straight through. Previously, we talked about making angles congruent in order to force two lines to be parallel. In this section, which is section 3-6, we're talking about the shortest distance between 2 points, or the shortest distance between a point and a line, and in this case, the shortest distance between 2 lines, all of which are a perpendicular distance. If I try approaching it at a non-perpendicular distance, I'm going to be traveling a much farther distance than if I were to travel at it in a perpendicular way. This is where the term moving right at something, literally we're moving at a right angle to something. So it shortens the distance to a minimum. So how do we do so? Well, we have some things we need. Ultimately, to find the distance between two lines that are parallel, we need to find the distance between 2 points, one on each line. Those points, however, need to be on a line that's perpendicular to both of those parallel lines. So we can choose the first point we use. From there, we then have to construct the other point, and then we can use the distance formula to find the distance between those 2 points. So I look at my example. We have two equations here. We want to find the distance between them. Graphically, if I were to graph this, these two rough sketches show you the equation y equals 4x plus negative 4x plus 7 and y equals negative 4x plus 2. Our job is to find the distance between these two lines. So first thing we need is to collect one of the points. And I find that the easiest thing to do is to choose one of the y-intercepts. It makes life a lot easier for us. So I'm going to choose this y-intercept. This is on negative 4x plus 7. So that's my first step, and I'll be referring back to this repeatedly. So let's choose a point on that line. It's going to be 0, 7. So first thing we did is we chose a point. So we choose a point on y equals negative 4x plus 7. And that point we're going to choose is going to be 0, 7. That's the y-intercept. And we're going to call that A. We're going to use him later. So there's one of our points. We have found the first point. Now we're going to need to find the second point. To do so, we need to know what this perpendicular line is, get an equation for it, and then find where it crosses our second line, crossing this line here. So the next thing we need in order to get this equation is we need the slope. Well, that's going to be perpendicular to the slope. So part 2, I guess you'd say this was part 1 of 1. Part 2, we need to find the perpendicular slope. In this case, that would be the perpendicular slope to negative 4, which, as we know, is the opposite reciprocal. Opposite means the sign changes, so it's going to be positive. Reciprocal to positive 4 would be negative, would be 1/4, excuse me. So that's our slope. Now we can write our equation out. So in slope-intercept form, that would be y equals 1/4 x. And normally I would put plus b here. And then I would substitute in this point to x and y to figure out what my intercept is. However, the intercept for us is still going to be 0, 7. You can see that visually in the picture. This is our point. This is our line right here. It's passing through the same intercept. So that means we can put our intercept as the same as our original equation. Okay, so we've got our equation. Now we need to know where this equation, which means the line, the perpendicular line, intersects the second line. So this is part 2. So I need to know where y equals negative 4x plus 2 and y equals 1/4 x plus 7 intersect. So I'm treating this as a system of equations. And this curly bracket indicates that I'm looking at them simultaneously. So I need to solve them. There's 3 ways we could do that. We could graph them, and then see where the intersection point is. Perfectly legal way of doing this. Or we could use one of the algebraic methods, which would be to either use elimination or substitution. For my purposes, I'm going to use the method of elimination. That means we're going to combine these two equations, either adding or subtracting them, in order to eliminate one of the variables. In this case, you can see that the y's both have the same coefficient of 1. So if I were to subtract these two equations, like so, I should eliminate the y variable. Y minus y is 0. Excellent. Now we just have one equation, and we're only going to have one unknown, namely the x's. And now I get negative 4x minus a quarter x. Well, that's the same as negative 4x plus a negative 1/4 x. That could be written as 4 1/4 x. But 4 1/4 x looks kind of clunky. So I'm going to convert 4 1/4 into an improper fraction. That will become 17 fourths, negative 17 fourths, and then of course x. So this is just negative 4 1/4 converted into all quarters. Right? 2 minus 7 is a negative 5, so now we have an equation that we can solve for x, and once we know that, that'll be our x coordinate. So I'll do the work up here. So I'll start with the original. 0 equals negative 17 fourths x minus 5. I'm going to add the 5 to the other side. So I get 5 is equal to negative 17 fourths times x. Now I need to get x by itself. You could divide both sides by negative 17 fourths. That's fine. I prefer to multiply by the reciprocal of this number. That'll make this become 1. So the reciprocal is negative 4 over 17. And I need to do that to both sides. So I'm going to multiply both sides by negative 4 over 17. So this will cancel out. This will become 1. And if you need to check, that's fine. Negative times a negative is a positive. 4 times 17, that's 40. That's 68 on top. And of course, 17 times 4 is 60 on the bottom. So you're going to get 68 over 68, which is, of course, 1x. So on the right side, we get x, 1x. We're good. On the left side, I'm going to multiply these two quantities. Please be careful, my young friends. You do not multiply this 5 times both numerator and denominator. You do not do that. Multiply the 5 by the numerator only, because this is the same as 5 over 1. So you multiply numerators, you're going to get negative 20. 17 times 1 is just 17. So this is my x coordinate. And we can confirm that, because that looks, if I convert it into a mixed number, this would be about negative 1 and some change, about negative 1 1/6, around there. So if I look at my graph, the point of intersection between that line, the perpendicular line, and our second line, it should be a total of about a 1 1/3 units in the negative direction. So 1, negative third. So right about here, sure enough, there is our point. It is definitely the right point. So that means our answer here is sensible. It's what we would expect it to be. From here, we now need to find the y coordinate. So I need to plug this in or substitute into one of these equations. I'll choose this one just because it's a little bit easier to look at and manage. I'm going to substitute this in for x, and that will let me to find or determine my y value. So let's see, I'll do that up here. So we get y is equal to negative 4 times the quantity, negative 20 over 17, plus 2. All right, so here we go. We'll quickly simplify. Negative 4 times 20, negative 20 is positive 80 over 17. Normally people would want to drop this 2 down, but I know I want to add this fraction, this improper fraction, and this number. I'm going to convert the 2 into 17th. Same denominator, you can add them together. So I'm going to multiply by 17 over 17. It's like multiplying by 1, so it's not changing the 2 at all. It's just converting it into a fraction. So this will become 34 17ths. Now I can add them together, and when fraction addition, you just add numerators. You get 114 over 17, and this is my y value. So my coordinate should be negative 20 over 17, comma 114 over 17. Now, this number, it is approximately 6, positive 6, and some change. So that's where our intercept should be in the y direction. So checking real quick. If I move up 6 units, 1, 2, 3, 4, 5, 6, and a bit of change, sure enough, that is exactly where that intersection point is. So this is, in fact, our second point, the point where the perpendicular line crosses our second parallel line. So we have found the second point. So all of that work was just to find this second point, which I'm going to call B. So here's the first point, got it. Here's the second point. Now we are in the home stretch. We just need to find the distance between these 2 points. And for that, we use, aptly named, the distance formula. So the distance formula is square root of x2 minus x1 squared plus the quantity y2 minus y1 squared. And now at this point, I would be safe in using decimals. Some of you are wondering why I didn't use decimals from the beginning, because it perpetuates an error. And we do not want that error to perpetuate itself all the way through. So our answer will be the square root of, and now if you want to use a calculator, that's fine, because we've done all the hard work, all the heavy lifting's out of the way. I'll write out the actual equation here. So subtract my x's, square that. And then add on, let's see here, the y is being subtracted, basically the distance between them. So 114 over 17 minus 7, that's being squared. So I've already calculated this. This comes out to be roughly 1.21. And if I have time, I will show you this as well on Desmos, because that's a fantastic way of checking that all of our work here is correct and allows you to check your work at home. Thank you very much. Again, this is Mr. Duncan from Victory Early College High School, and I'm just demonstrating how to find the distance between 2 parallel lines. So we found to be 1.21, and if we look at our picture, it would appear that that distance does appear to be somewhat more than 1, but definitely less than 4 or 5. So the distance here definitely feels sensible that this is the right answer. All right, that is all.